All right, so let's get started. First off is Alex Eagle. So Alex, come on down.
Thank you. Good morning, everyone. It's really an honor to be given the time slot of day 2 keynote, which is definitely not something that I'm qualified to present to you. So I know I'm jumping ahead of the talk a little bit, but I want to let you know that not only that, but I had very bad sleep last night because the talk you're about to hear is very unusual, not something I've given before, probably not something you've heard before. There's going to be a lot of honesty and revealing myself to you. Also didn't sleep well the 2 nights before that, so I don't really know what I'm going to say exactly. It's going to be almost as much of a surprise to me as it is to you. Hopefully a pleasant surprise, but I can't really promise anything. Yeah, let's get started. I should say I've been wanting to give this talk for a very long time. This book is old. It's from sort of different days in America. I kind of liked it. It was on my shelf for a long time, and it's non-grammatical, which is why my talk is called "I'm an Imposter, and So Can You." It's really just that I wish I was as funny as Stephen Colbert, which I'm definitely not. But it's something to aspire to. I've been wanting to give this talk since I was on the Angular team, and I sort of started giving conference talks, and I felt like being the person standing here with the microphone is a big responsibility, and you want to sort of convey some sort of expertise, because surely there's some reason that the organizers chose to accept this talk, so I must have something useful to say. And I've never really seriously pitched the idea of giving this talk, but I was inspired by Igor Menard, the tech lead on the Angular team, who gave a conference talk at the Angular conference. This is a very big conference, 1,500 people or something in the room. And he gave a talk that was really non-technical. It was more emotional and about being a developer, which I thought was great because he could give a ton of great technical content. But that's somebody that I think I was really inspired to hear that from. Okay, so we're going to spend a long time on this section, which is unusual for a talk. About the speaker. Okay, so here's my bio slide. Let me see what it says here. Okay, founder and CEO at Aspect. That was my product talk yesterday. We're not going to get into that. It says I was ex-Google for a while. Software engineer is what SWE stands for. As a tech lead on systems adjacent to Bazel. I've sort of been working on Bazel since 2008. But notably not on the Bazel team itself. I was never actually granted a position on the Bazel team. So we're already into sort of questioning. Sorry, it's not time to question this yet. Right now I'm confident. Okay, so my bio's great. Okay, so that's the first bullet. Okay, second bullet, I was the tech lead for the Angular CLI. This was we had, I think, probably 1.2 million users at some point. Pretty big responsibility. There was a time when Angular was by far the most popular web framework. Maybe there's something to talk about there. Right, and then I founded Aspect to bring Bazel's promised benefits to all developers, which sounds very grand and ambitious. Okay, but this is not true. I was actually hired as a software engineer in test at Google in 2008. And depending on who you ask, software engineer in test is a different job ladder than software engineer. Job ladders are very important at promo time. You have to claim that the things you've done are the things that you were expected to do. And the question was always, are software engineers in test expected to be able to do all the things software engineers do? So software engineers can build these massive services and deploy them to Borg and have they can build Google Photos, and you just type in a search term and it finds that in your photos. This was before everybody expected that machine learning had gotten us to the point where, of course, the computer can just find the photo based on the text you enter. It's never clear if the interview process for software engineer and test was held to the same bar as it is for SWE. So maybe I was hired at Google under the pretense that all I could do was testing and not actually do software engineering. So I'm going to have to start adding some red sections to my bio here. This is very questionable. Not only was I hired as a software engineer in test, but I did eventually switch over to the software engineer job ladder, but without re-interviewing, because there was some manager at Google who felt that the process should be made more easy for people to change job ladders, because legitimately sometimes people feel like they want to do something different with their career. And so they temporarily did away with this requirement that you re-interview in order to become a software engineer. just later to reinstate it. So I snuck through this little window and was able to put software engineer on my resume because it's not a lie. But do I really feel like I was a software engineer at Google? I don't know. Okay, it's going to get worse. So yeah, I was the tech lead for this Angular CLI project, and the CLI was a build tool, and we all know a few things about build tools, but I had no idea how to write an Angular application. I really didn't know how to write a front-end application at all. I remember the day I got my first day at Google was the morning I got in the car, and on the radio they were announcing this Google Chrome browser, and I was really excited because I thought, so Google is going to solve the problem of me having to do everything in a browser, which I don't really enjoy. I would rather have desktop applications. I'm sure Chrome is going to have a way to switch my banking site and my code review tool and all of these things to be sort of feel like desktop applications, because I was really uncomfortable with things running in the browser. So I became the tech lead for a framework that 1.2 million people were using to write apps in the browser, which I didn't feel was a good idea. And then I would give conference talks. I had one in particular to this large conference, and I could not write any of the code that the attendees could write, and I could barely read what they wrote. And as sort of a build systems person, I was always looking for compiler errors. So I was pretty familiar with the kind of errors you would get from the compiler, but I had no idea what the application would do when it ran. And so sometimes people would say to me like, after we compile it, we're going to run it, and then something, and I sort of give them a blank stare, and I'm not sure what language they're speaking. So we're gonna cross that one out. While we're at it, I don't know, all developers seems kind of grand. And in fact, I'm standing here now giving you a talk about imposter syndrome. I am not an expert on imposter syndrome. So it's sort of ridiculous. It seems like if you want to hear about imposter syndrome, you should find somebody who really knows about imposter syndrome, but I'm going to try to give the talk anyway. So yeah, I am in fact an imposter. Imposter syndrome is this idea that other people have an expectation that you know something, but you don't think you actually do know that thing. And it might be that they've told you that that's the expectation. That's kind of rare, I think. A lot of times you infer the expectation. You see that your coworkers seem amazingly adept at understanding some detail about a data structure, or the reason that memory is retained from the analysis phase into the execution phase, or exactly how depth sets work. And you feel like you probably should know that stuff as well as they do, but you don't think you do. It may be that you give yourself a really high bar, that like you've projected to other people, just like you do if you're standing on stage at a conference, that you're really competent and you're an expert on things. And then privately you feel like you've been marketing yourself a little bit beyond the point that you could really back it up with facts. And if you got into a conversation with an expert and you were trying to convince them that you knew all of the things that you said you know, you're not sure that you would really convince them. And maybe they would tell you, it doesn't really sound like you know what you're talking about. But even worse is that they pretend that they think that you do know what you're talking about, but really inside their heads, they're thinking this person is clearly an imposter. And so really my objective in giving this talk, at least the first half, is to reveal myself in this very personal way that I really know much less than you might think, or less than I would expect of myself. And that's okay. And I think there's a lot of value in having someone try to make something feel normal, especially in this world of social media where we all have a really nice polished outlet on LinkedIn to present ourselves in the best possible light. It's really unusual for somebody to go on LinkedIn and post that their project actually didn't work out, they got moved off the team, and it was really actually their fault because the design that they came up with was much too ambitious for the amount of resources that they could reasonably get on the project. They didn't really understand how to pitch it to all the relevant stakeholders. They didn't want to have to talk to their skip level about why their project matters. That's not the sort of thing that you read. And so we all easily get this expectation from reading what others write about themselves that that's accurate, that that's sort of, but in fact, they're presenting the little thin veneer that they want to the world. Of course, we all do this. So maybe some of you feel like a fraud because you don't have the level of expertise others expect. And I considered having a sort of let's raise our hands at this moment. But of course, I'm the only one who's expected to be brave enough to raise my hand and say, yeah, that's me. But I would like for all of you to imagine raising your hands if you think you might be an imposter. And I'll pause for a moment while you're imagining. Okay, most of the room. Okay. Okay, I have a question already. If you don't feel that you're an imposter, can you pretend to be an imposter? No. No, please don't. I mean, you could, but then you might make other people feel like there are many imposters in the room when there aren't. Maybe a couple of people are the only ones. So we don't want them to get the wrong impression. In fact, it probably is about, according to this survey at least, which is about all tech employees, and we are one slice of that, but very common, more common than not, that engineers feel to some degree that they are an imposter. And from the same site, they give some tips about how to deal with imposter syndrome, and I want to try to step through these briefly, because I feel like in good faith, if I feel like I'm able to be effective as an imposter, maybe I can help those of you who imagined that you were raising your hands. So, of course, number one is acceptance. And I mean, all of these sound really obvious, and I had to dig through this a little bit at 2 a.m. this morning when I was walking around the park here wishing I was asleep. So acceptance is really confessing this thing to yourself, because the first person that you're trying to fool and maybe the most critical person for you to convince is yourself. So this step one is to stop trying to convince yourself that you're not the thing. And I think this has a lot of danger with it, because for a lot of us, our own self-esteem and ability to present ourselves at work is perhaps based on having convinced ourselves that we couldn't possibly be an imposter. We know all the things that we said we know. They're on the resume. Like, I'm sure I can show up to work and prove this to my coworkers today. But from what I read on this website, the longer you sort of try to fool yourself, the harder it can be to work your way back out of this problem. Learning to be comfortable with the uncomfortable. This is sort of like how to see without seeing or something. It sounds metaphysical and impossible. I think this is an attitude of showing up to situations, being bold and brave, and thinking that no matter what happens, you'll be okay. It's an adventure. Stepping into a position at work that you don't know much about is the great unknown. It's what makes life exciting. Step three, I have my best friend says, comparison is the thief of joy, which is a nice little concise way to express that it's really hard to feel fulfilled if you're always looking at what other people have. And in fact, I think there's a broader lesson from this, which is that we all tend to assume that other people know most of the same stuff we know, plus some more. So I assume most of you know the things I know about Bazel, but also you probably know like how a depth set really works under the covers or something. I listen to talks from someone like Fabian, and clearly he understands a lot more about Bazel than I do. I assume he also knows all the same things that I do, plus some delta, right? But part of this idea of comparing yourself is that there are things that you know that the other person doesn't, and because they're trying not to be an imposter, they're not going to really tell you that a bunch of the things you know are not things that they're experts at. Number four, give yourself credit you deserve. I like to think of this one of the smartest engineers on the Angular team would sometimes, I think, fall into this mental trap of thinking that failures were earned. So every time something screwed up, I could have done something better about that. This was probably my fault. While successes were luck. Oh, this went well. It seems like probably somebody else contributed a lot, or I just didn't have the sort of obstacles that I might have had with this project. And attributing things to luck or skill is, of course, a judgment call. And so you're free to make the opposite judgment, which I think is much more beneficial in your career and in dealing with being an imposter, at least in my experience, which is to just go ahead and assume that successes were earned and failures were bad luck. Who's to tell you otherwise? Number five, reach out to your seniors. Other people on your team have things to teach you aside from technology. This does require opening up to them a little bit, but they may have been an imposter. I mean, 58% of tech employees thought that they were. They might still be an imposter like me, and so they might tell you things that you're surprised about. Maybe that helps you feel like it's more normal. And of course, develop a never give up attitude. I mean, this is sort of, what is this, like an inspirational talk about anything in life? I don't even know, how did they give me this slot? This is really a day 2 tech note, keynote. It doesn't feel like it to me. So anyway, I'm not going to give up. Okay, we're going to keep going through this talk because I'm just going to be brave. And I think there's something about never give up where if you look at the trajectory of the rest of your career, starting from this moment, sitting in a chair or on the floor, sorry, and you know, up till you're finished and you've had like whatever successes you'll have and retire, right now is the moment that you are the least knowledgeable and experienced of all of the time from now on, right? So like, I think never give up is also a little bit of, over time things change, and if you wait, waiting has a lot of power, right? The same way that water carves a river through a mountain, time has a lot of leverage, and so if you just keep trying, like, you probably will be improving over time, and you'll get out of this moment that you're in right now. I hope I will. Okay, so now I'm going to try and pivot a little bit and give a talk that's relevant to BazelCon and developer infrastructure. So I'm going to zoom into number 2. We'll go back up that list for a moment, and this is what they wrote. Maybe you have a colleague who is an expert in a language you know nothing about. Maybe the situation might make you uncomfortable. It might make you think you know nothing. It might make you a little bit afraid to go up to this person and just start giving them details about this language, and clearly, like, it takes a long time to learn a new language, right? And to be proficient in it. And so I think this is the key to why developer infrastructure engineers, in my experience, are often feel like imposters, which is that the more languages we have to deal with, the better the chances that you can't possibly know all of those languages. And yet you have to interact with colleagues who do know those languages. And so you're forced into that same uncomfortable position. And if you can learn to be comfortable with the uncomfortable, I think that helps a lot with being able to go to your colleagues who work in all the languages in your repo, you know, and probably they're always trying to add new ones, and you're like, oh my God, I have to learn Rust, and then you look at the syntax and it doesn't really parse in your brain, and like you don't even know how to start. That's how I feel about Rust. But I better pretend that I know it, because I think we're gonna try to contribute to Rules Rust or something. I'm sure it'll be fine. Yeah, it'll be fine. So here's my framing of why it's okay for you to not know all the languages. Okay, so let's take an analogy with product engineers. And in a lot of cases, the product engineers on your team are the language experts. So these are the people that you're a little bit afraid to be outed to. You don't want them to discover that you're a fraud. Do they understand the user data that's stored in the system that they've built? And I think the answer is pretty clearly no. The users of their application are probably in some domain that they're not an expert in. They're an engineer. Like, in some companies, engineers have a background in the domain that they're working in. If you work in robotics, maybe you have a background in linear algebra or something. But across a wide system, especially a generalized software that is used by lots of different people, you'll never understand the data that they're putting in there. It's a total mystery. You couldn't learn all these domains that they work in at any depth. And so what are the things that you do care about as a product engineer? Well, you have a data schema. So there's some layout of how the data is stored at rest. There are invariants about how that data has relations with each other. There are logical constraints in any application code that processes the data. And then sometimes you have to do data migrations. And so you know enough about that so that whatever data somebody stores in your system, oh, well, you know, they violated the schema, so they can't store that data in the system. I don't understand what that data is. So I think this analogy carries over pretty neatly to developer infrastructure. Except in our case, our users are the product engineers. And so they're also widely varied. You have ML researchers who are doing something that only in the last couple of years anybody really cares about. Working alongside embedded real-time systems engineers who, you know, they care about kilobytes of memory for some reason. People working on user interfaces, like that Angular app I talked about. JavaScript happens in there. And so all that code is a mystery. And you can't possibly be expected to learn all the languages and frameworks in any depth that your users are using, right? And what you do care about is the data schema, the invariants about how the schema relates to each other, how to migrate the data, how applications should process the data, right? And in our case, applications are things like build tools, static analyzers. The data schema, I think, is kind of key. And I'm going to get into that in a minute. But first, I have one more aside, which is that even if we've accepted, we take step 1 of the list of 6 things, and we accept that, oh, I'm kind of an imposter. Yeah, this image was generated by, what's the chat GPT thing that was before text? DALL-E, yeah, thank you, DALL-E 2. Because I asked it for an engineer going to the well to get water with their laptop, and it did. It's very good at that. Okay, so what on earth is this person doing? So this is my extended metaphor for developer infrastructure in general, which is that product engineers if they come from, let's say they come from a single language, they're used to using the build system that comes with that language or whatever the framework recommends. And they end up having to learn a little bit about build systems. They end up having to dive into essentially a lot of details. They're the build cop. They have to understand the optimizations that take place before they ship artifacts. Maybe they have to be the release engineer. So it's kind of like they live in a village and they go to get water from the well, which is not to say that people who live in villages are doing something wrong. Clearly, like that's where you get water at that scale. But if you're using Bazel, you're probably in a monorepo. You're probably trying to approach something at scale. And so what you're doing is providing municipal water supply. And you're telling engineers, hey, don't go to the well. You can just turn on the faucet and water will come out of it. And at first, like they're not used to doing that. So you're trying to get them to change their behavior, right? And you're trying to provide a service that you think is really useful to them. And sometimes it's baffling why they, number one, don't want to use the faucet. But then number two, once they start using the faucet, they just think water magically comes out of the faucet. And it's a very thankless job, I think, to be developer infrastructure engineers, because our users take these things for granted. Outages are horrible, but they don't notice when things work, right? And so as developer infrastructure engineers, we're trying to encourage them to change their habits, and we're in fact sometimes making rules. We're the governance body in many cases about what practices are allowed in our monorepo. And so if we don't understand their code, but we're telling them how to do their job, then that's an obvious recipe for feeling like an imposter. And so my recommendation is, yeah, go ahead. We have like those 6 steps of how to deal with it, use those, and go to product engineers and pretend to be the expert. So I only have a few minutes left, but I want to try to tie this even more specifically to Bazel. I think the specific practice that I like to employ, and I'm a little embarrassed to be in Germany saying this because, I mean, in California, it's fine, is let's just be non-rigorous and think that all languages are basically the same. I mean, how different could they really be, right? I mean, there's interpreters and compilers, but other than that, they're pretty much the same, I think, mostly. From the point of view of the developer infrastructure engineer, that schema that I talked about is the thing that all of our user data has to conform to. And so if we can make all languages pretty similar in terms of the schema of how the constructs that we store on disk in Git are related to each other. Sorry, not everybody uses Git. I know there's still a lot of Perforce users here. So the schema is roughly the following. And I'm not going to try to, I have a few more slides, but I'll try to illustrate part way. But I think I'm just hoping to paint the picture here. So you have third-party dependencies. Developers choose what packages they're going to use. They express those somewhere in a file. Our job is then to resolve those dependencies transitively, ideally pin them for supply chain security, have integrity hashes. Then we need something to download and verify those. It might be RCTX download, like the Bazel downloader, but it might be other tools. Those dependencies all have to be installed on the disk. Okay, that's every language. We have to do that. In some cases, the dependencies also have to be compiled. In some cases, they're static. And we have to build a program. So now we start from the import statements. We construct a dependency graph. Bazel does the loading and analysis phase. Then it needs to fetch all of the tools and runtimes involved. Run those tools, ideally with just the run binary rule. I recommend highly. And then they either have to statically or dynamically link things. And when I say link, it sounds like a C++ term, but really all languages have some concept of symbols that are foreign to the application that you've shipped and therefore need to be resolved when the program is running, right? So that's the third step, is when the program runs, it has to have some way of resolving dynamic links, which is to say, in JavaScript, going and fetching more bundles from the server. Or it could be, it could be the run files library involved over here, because that's the way you expect your program to resolve these things. And so just to illustrate, I mean, the beginning of that, I said developers express their dependencies. They write this. Probably at least one of these languages, somebody in the room does not feel like an expert in. But this is basically the code that's checked into your monorepo, right? So you're supposed to kind of roughly squint and pretend it's pretty similar. And yeah, I mean, other than the first line, I even have them syntax highlighted the same, which makes them look really similar. So then there's just all these different mechanisms. And as you context switch between languages, if you can find the commonalities here, so for third-party package constraints, there's some sort of semver range. And so in C++, how do we do this? I guess it's the module.bazel file, because there isn't currently a packaging format, although I hear one's being discussed in the C++ community. For Java, you can use pom.xml, although that's kind of specific to Maven. And I think build.gradle has maybe a different way. Very much hand-waving. Swift has a package.swift file. JavaScript has a package.json file. Python has requirements.in if you're going to lock things. So that's not what everybody does. Some people just call it requirements.txt. Go is nice because you can just run go mod tidy and it figures this file out for you in basically all cases. So I'm just going to take this forward partway through the steps, like I said. we want to resolve the dependencies. You'll see something like this. Either it will become an equals equals. Ideally, there will be hashes. This is Python over here, but they all kind of similar. And this is a different lock file in all cases. And here I have even more parentheses because they're not really the same, but they're pretty similar. So you run pip compile to get a requirements lock file. The Maven install file, Simon explained to me why there is no lock file in the Java world that actually works. And so rules JVM external had to invent one. For Go, the go.sum file, once you switch to Bazel mod, the go.sum file is read by Bazel, and so it's directly used as the input that pins and provides the integrity hashes for all of your dependencies. Then at some point, you want Bazel to understand the dependencies, and so ideally Bazel's the one doing downloads, but in some cases like Python, it's pip that does the downloads. Some small differences, but at some point you want to have a dependency graph, right, in the external folder, so you're going to be able to write deps that point to third-party packages. The package manager is going to install the things on disk. And so, sometimes you rely on sort of class loader or runtime shimming tricks. Rules Python depends on tricks like this. But Matt will talk later today about rules Py, where we instead just create a virtual env so that all the standard tools work. So there are different ways of doing this. Every language has to do something like this, right? And then just imagine that I had enough time to continue, or imagine that you were interested in hearing me talk anymore. And I would tell you more things that are kind of similar about languages. There are really too many of them to get into, and I'm just hoping that this framework gives you a little bit of bravery to go into your product engineers and pretend that you know more than you really do. Okay, so thank you. With that, I think I have a few minutes left for questions, and I'm happy to take questions that are not about being an imposter. Be brave.
Alex, thanks for the talk. For context, I consider myself a C++ developer who happens to transition to Bazel because the previous build systems have been stupid and slow, of course. I'm wondering with how you approach it, the difference between developers and build system dev infra engineers. How do you hold developers accountable for improving what they did? So historically, the build systems allowed a lot of dependencies which might be useless. And like include what you use would help there a lot. Who is responsible for cleaning that up in your point of view?
Yes, so this is a good question. It's a sort of a specific thing that developers should stop going to the well, essentially, and follow practices in the environment around them. I mean, there's always sort of the carrot and the stick for this, right? So one is to sort of show them a nicer way of doing things, give them optional tooling to understand things like cyclomatic complexity. You could present somewhere, you can run static analyzers. For third-party dependencies, you can run some tooling that helps them understand which of their third-party dependencies are very out of date. There's an education component to that where they need to understand why they care about third-party dependencies, and I think code review is a great opportunity to give people career growth kind of feedback in that sense. So if your code review system, if you can present things there that show, maybe what you're doing here doesn't make as much sense. And then there's the stick where you simply say, we're going to outlaw something, which is also valid. I think that has to be applied very carefully. Number one, I would say in the context of Bazel, don't try to change their practices at the same time that you're adopting Bazel, because migrations that do more than one thing are more likely to stall, and it's difficult to attribute problems that come up to which part of the migration caused them. And code is easier than people. So when we're trying to change people and we change more than one thing, it can be very difficult to ascertain what change it is that caused the developer satisfaction survey to plummet. And I think setting up a developer satisfaction survey is important, because any of the ways that we try to force developers to improve what they're doing, we always have to do it with a mind that they appreciate that and are coming along willingly, because it's like telling developers they have to use a different editor. You can take it from their cold dead hands.
One more question? Be brave. All right. Well, thanks for a great talk, Alex.
Yeah.